In this example, we're going to look at how to change each of these four logarithms into an exponential. Because of course, we've seen in the past that I can take anything that is written as a logarithm and rewrite it as an exponential. All we're doing is just rewriting it in a different form. It still means the same thing, it's just a different way of writing it. Just as much as I could rewrite something that looks like this to look like this, and they're still equivalent. It's just a different way of writing a mathematical sentence. In this case, we're going to be writing an exponential. The very first thing we're going to be putting in is the base value. Now, notice that b is the same as b here. That's where I'm going to go and get it from. I do read that as the base of the logarithm. Then, the next thing I'm going to write in my exponential is my exponent. Now, notice that log is always equal to the exponent, and that's a good way to be able to remember what that is. And if you remember those two pieces, then you'll always be able to remember then what it's equal to, because it'll be equal to the third number. All right, so let's do this with each of our examples. The very first number I'm going to write down is the base, which in the case of this problem is 5. So it's going to be 5 to the power of whatever log is set equal to, because log always equals the exponent. And so if we know that much, then all that's left is the equals y part of the exponential. And so it equals whatever we haven't used yet, which is the 3. And so then that is our exponential equation. That is equivalent to the original log. All right, next problem. Same basic process. The very first thing I'm going to write is the base. The base of my logarithm here is m. So it's going to be m, and then it's going to be to the power of, log always equals the exponent. And so in this case, it's equal to a. So my exponent is a. So we have m to the a equals whatever is left, the 8. Now you might be wondering, the first one had parentheses around it. The second one didn't. What's the difference? None. They both work the same way. I did it both ways because I want you to see that it works both ways. Next one. I again am writing it in exponential form, and the very first thing I write is the base. Now the base is whatever the base of the logarithm is. Now I know the log is written on the right side in this problem and not the left side like the last problem, but that's okay, that doesn't matter. The base is still that small number written right after log. And so it's going to be z to the power of, my exponent is always whatever log is equal to. In this case, it's on the left side. It's equal to 14. So it's going to be z to the power of 14 that is then set equal to whatever is left, the g. All right, and then our last problem here. I'm writing it as an exponential. The very first thing I grab in my exponential is the base. But there's not a base written here. There's no small number written like there was up in the previous problems. Well, this takes us back. We got to remember that when the base is not written in here, it is assumed to be 10. So I could actually write this as log base 10 of 42, and it means the exact same thing. Knowing that allows me to now rewrite it as an exponential, because that means that this problem is actually going to be 10 to the power of h equals 42.